Let me introduce myself. I used to work at Google, then ran my startup Future Camp for a few years, then worked as a CTO of a startup. I now work as a part-time CTO with multiple companies. Today, I want to discuss mutability. Mutability means changing the values of variables. In a sense, you can say that's all that happens in any program. Variables change their values. That's what happens from beginning to end, right? There's nothing in programming except changing the values of variables. Unless you're into Haskell, but that's a different conversation. And why is mutability important? Because all bugs arise from unintended mutability. Any bug happens because some variable representing something got into the wrong state. So controlling mutability is a critical aspect of code quality. So let's see what we can do to control mutability. First, programming languages offer let and var. Let means it can't change. Var means it can. And different languages have different terminology. Kotlin has val and var. JavaScript has const and let, right? Whatever the syntax may be. Java has final. Use this. So in this case, these three arrays can change. Here it matters less for a local variable whether it's mutable or not. Let's take a different example. This is analytics data. It captures analytics about a photo or a video that's being captured. And the mode type is what mode are we in? Are we in photo mode, video mode, time-lapse mode, etc.? That can't change, right? If you're capturing a video and you're recording analytics for that video, halfway through the video, it won't change into a photo, right? So that's a let. Whereas other things are var. If you're recording a video, you can zoom in or out. So the zoom level can change. This is one thing. The other feature that Swift offers is private set. This can be accessed by everyone, but set only in the same class. These again prevent unintended state changes. In this case, this is the only place where it can be set to true. And if your language doesn't offer it, you can of course have separate ones like this. You can have var started session. This is a computed property. You have a separate impl. And then you make this private. Private var started session impl equal to false. So the concepts I'm explaining are not language specific. They're not specific to Apple platforms. Then you can also have append-only data like this. You can never reset them. Whenever you update it, you are appending something to each of these three arrays. That way, you're enforcing that the state of this class can change only in a certain way. People can't remove things from the end or the beginning or change the existing values. If the values are 0, 1, 2, people cannot change it to 2, 2, 2. The only thing they can do is append something, right? So this is a controlled state change. In this case, the attitude mapper tracks the position of the iPhone in 3 axes, yaw, pitch, and roll. And it uses the sensors, accelerometer, gyroscope, compass, etc. to track this. And they give you a bunch of readings, maybe 30 times a second or 10 times a second, which are all stored in this array. And you don't overwrite earlier values. It doesn't make sense. So it's an append-only property. Another example of a controlled state change is a variable that can go only in one direction, from false to true in this example. Started session starts with false, it can become true. Or you can have values that increase. For example, we take the number of time lapses captured and we store it persistently, again for analytics and other reasons. We have a limited number of free photos and videos and time lapses that you get. Once you exhaust that, you have to pay. So for all these reasons, we store the number of time lapses taken. And again, that is encapsulated within this helper function. You can increment with the key, and the key is private. See? So you can't access it directly and increment it. You can read the value or you can increment it. You can't set it to a random value. So this is another example of controlling mutability. You can also control mutability to prevent out of range values. For example, the zoom level of the camera. Setting too low a value is not a problem. The setter handles it. So if it is less than 1, it increases it to 1. So again, the range of this is controlled to valid values only. You can also have a size limited data structure. This is an array with a maximum size of 30. It can be smaller but never larger. And if it becomes larger, the first element is removed. And the next element is added at the end. It's appended. So it's like a rolling window. You can also control when a state change happens. For example, camera apps have different modes like photo, video, time lapse, and you can change between them, but only when you are not recording. So that's what this check ensures. The UI is hidden, so it should not be possible to change modes anyway. Next time you use a camera app, start capturing a video, and you'll notice that the mode switcher is hidden. The same thing here, except that there was a bug that was causing the the mode to change. So one aspect of controlling mutability is defining when a state change can happen. Another example is checking assertions after a state change happens. Let's see if I can find an example for that. So here, for example, you can set this to nil only if something else holds. Otherwise, you are in an invalid state. So you can check before or after. In this case, this is a did set. It's called after it is set. So think of this as a post condition, whereas the earlier is a precondition. And you can use this to check other state as well. If I do this, then something else should happen. Otherwise, the function hasn't done its job properly. You can also perform changes when something is set. So for example, some modes are locked for free users, and this property is paid upfront, is paid, controls whether the user is a free or a paid user. And when the user pays, this is set to true, and this notification is posted, and someone listens to it and unlocks the modes. So this is a case where setting this thing to true or false causes the UI to update to unlock the features. So that's another way you can tie state changes to actions. Sometimes you can have two options that conflict with each other. The iOS camera lets you capture a photo or a video, but you won't want to capture both at once. The way you capture a photo is you add a photo output to the session. This is a video session, the camera session. And you would remove the video output. So here you have a mutually exclusive thing. You would use either this or that, but not both. Again, you can ensure that that is respected here by having the function that adds one remove the other. So you can never get into an invalid state of having both present at the same time. Another example is a variable that can be modified only on a specific thread. I don't think I have a good example. Yeah, but if you have a variable that is used concurrently from multiple threads, it will get corrupt. So you may want to modify it only from one thread. Another example of state changes is using the IIFE pattern, immediately invoked function expression. It comes from JavaScript, but it's available in Swift as well. So if you look at this, which is a date, you're creating a date formatter and parsing a string to create the date object. This requires multiple steps. You have to create the formatter, then you have to set the format, then you have to parse the string and then return it. And all this is in a block or a function which is defined and immediately invoked. So it's an anonymous function. This ensures that this is never in an invalid state like null. The more conventional C approach perhaps would be to say paid up front cutoff date, make it nil, and then have something like init cutoff date. And here you would do this, right? So this is a second or the more conventional approach. The problem with this is someone might access this before this got invoked. It's even harder if you have multiple threads. So here there's a possibility that the state is invalid, like nil. Now you can avoid null, right? You can make it today, right? Whatever it is. But this is still, even though it's not null, so it's, I don't know, you could say it's better, but it's still the wrong date. And this also prevents you from making it a let, because it is starting with one value and then getting changed. So you can't use let, but here you can. And the IIFE pattern really helps in classes. So when you have a bunch of properties within a class like this ensures that each of these is fully constructed as much as possible before you access it. The traditional way is to inline all of this in the initializer. But then the problem is somebody could refactor code and move it up or down if you have a 40-line initializer or constructor. So if you do this, you could do this. Let us initializer. Let's say you could do this. It's called video data output. This is the traditional way of initializing. Do you see the problem with this? You're creating some object and passing self. And this initializer might read the video data output before it is fully initialized. That's why you don't want to do that. That's IIFE pattern. The other thing is ensuring that state changes are valid and preventing unintended mutability is not always easy. So imagine a company that has an employee class, and we'll take Java now, right? And you have a, let's say, public list of equipment. Right? This is a list of equipment that has been issued to the employee, maybe a laptop, maybe a 4K monitor, whatever equipment, right? Company-owned equipment issued to the employee. Somebody can say this is not encapsulated. People can do whatever they want with this array. This is bad practice. In Java, you would make it this way. And then you would have a public list of equipment, get equipment, return equipment, public. Set equipment, list of equipment. People say this is better. Actually, this is not better. People can still set this to whatever they want by using this. You've just added an accessor, but you're not actually controlled. Here you need to have some checks. Otherwise, you're not actually restricting the mutability. So unless you're building an API where you can't change it later on, you'll break clients, don't write code like this in Java. It's dumb. Just make this public or package access, whatever it may be. And if needed, you can always refactor it. And IDEs like Eclipse have supported this refactoring for 15 years. It'll go find all the places and replace it for you. It'll just take a few seconds. So don't write all this boilerplate. But leaving aside encapsulation, we're not focusing on encapsulation today. This is still error prone. So let's assume this is not there. Well, it's not Python, but now is it correct to say that the equipment can't change? And let's say we create a new array list. Assume this is a program. Now you have removed your setter. Does it mean the equipment can't change? No, it can change. If I have an employee, I can always say employee not get equipment dot add a new laptop because it returns a list. So you have to be very careful about preventing unintended mutability. So here you have to return an immutable list. Collections dot immutable list of this. This is a wrapper class. Or I think internally it makes a copy. It's a defensive copy. unmodifiable list. That's what it's called. Okay, so it doesn't make a copy, it's just a wrapper. This is one technique to use. The other technique is a defensive copy. Just create a new list and return it every time. And all of these come at a cost, especially making copies of data structures that can have a lot of data within them. And you'll also have to make a deep copy if each of those objects in the list has sub-objects, all of these. So let's say you have done it this way, right? Now, oops, let's uncomment this and look at this. So this no longer works. It will throw an exception at runtime. And let's say you add a check here. I don't know. Let's say every employee must have a laptop. They can have other things as well. They can have a 4K monitor, but they must have a laptop. And suppose you check this here, right? I'm not writing the code, but assume this is not a comment. This is the code. Check that, right? If not, it will throw an exception. New external monitor. This won't work, right? Because it will throw an exception saying, well, there should be a list of. So here the employee is being deprived of his laptop. He is being given only a monitor. This will throw an exception, right? So you are happy. You are enforcing the invariant you want. But think again. So here I'm smart. I'm calling this with a list that meets the requirement. I create a list. I add a laptop to it. So this works. It says yes, there's a laptop. And then I reach into the list and change it. I'm replacing the laptop with a monitor after this guy has checked. So here also you need to make a defensive copy, right? List dot un ideally you would make the check here itself because this exposes you to a race condition. Someone can pass a list and in another thread they can modify it. So between the check and this, if they modify it, the check will pass and then they have modified it so the wrong equipment is stored. And there have actually been security attacks based on this. And the attacker just does it in a loop. They run it a million times. Maybe the attack succeeds only once. It has a very low probability of success. That's okay. They just keep hitting it again and again till it works. So actually what you have to do is this. Equipment equal to lists dot unmodifiable list of equipment. Then check this list. Then just do the assignment. Okay, so let's say you've done all this. Does it mean the equipment can't be changed except in this way? So suppose you add a commit. Always returns a list containing a laptop. Is this respected? No. You can have a subclass. This employee never has any equipment. It's always empty. Again, violating the condition. So you can see there are so many things that can go wrong. When you want to take care of mutability, you want to take care of objects having the correct state. Defensive copies need to be made, and there are many ways in which objects can have the invalid state or appear to have an invalid state. So in this case, internally the equipment array is correct, the equipment list is correct. But if it appears to have an invalid state, it has an invalid state because of encapsulation, people can't see inside the class. They'll just go with whatever this getter returns. So if the getter is returning an invalid state, for all intents and purposes, the class has gotten into an invalid state. It did not control its own mutability. Ideally, it should have controlled it so that it doesn't get into this state. So these are some things that we need to take care of in order to ensure mutability, which is important because as a first approximation, all bugs arise from unintended mutability. So to ensure good code quality, you need to take care of mutability as one of the most important things. If you'd like me to help your team, there's a link in the description.